Hello, today's exercise is to look at producing a smart map that is capable of analysing vegetation health from imagery such as this digital globe, colour infrared, multispectral imagery. To do this, we'll first build a spatial model using ERDAS Imagine. We'll upload that model to the smart map environment and edit it some more, and then create an actual smart map application that we can publish for use. So the first task is to go ahead and start the spatial model editor. So we'll begin the process of building our spatial model. We'll use this particular image just to test the model as we build it. So we'll drag and drop the image onto the canvas. We then want to find the index that we are going to use for the vegetation health. So we can search in the operators on index, and that will give a shorten our list of available operators. I can select apply index, drag and drop that onto the canvas. When I connect operators together, if I make a mistake, such as trying to connect incompatible ports, the connection will be shown in red. It gives me a good indicator that I've made a mistake. Simply disconnect that, reconnect it, and the black connector indicates we have a good connection. In this model, we're largely interested in simply relative health of vegetation. So the absolute index values aren't of interest. So for simplicity, we're going to go ahead and stretch the data to 8-bit. So we're going to look at our stretch operators and use an equal clip stretch. Go ahead and connect these. The raster information is going to feed into my stretch. I'm actually going to use a value of 2% off either end. And to perform a stretch, we need statistics. So I'm going to find my statistics operator, take in the statistical index values, and feed the statistics into the clip operation. We're also going to increase speed of processing. Connecting the ports correctly. At this point, we might want to test and see how we are performing with making a working spatial model. So we'll use a preview operator. We'll go back to our apply index. At the moment, we're going to provide a sensor name. And the index we wish to apply. I'm going to go ahead and split this view in half so we can use a preview. And in Spatial Modeler, we're going to click the preview button. Let's go ahead and link these two viewers. Now we can see as we roam around our World View 2 image, we can see the measure of vegetation health being displayed on the fly in a preview, in a linked preview view. Our basic model appears to be working, but a grayscale result isn't very easy to interpret, so we wish to apply some color to our analysis. Let's go ahead and turn off the preview, disconnect, because we want to add some more processing. What we want to do is apply a color table so that we can see a color ramped vegetation health rather than grayscale. feed in our raster information to the apply color table, we also need a color table. So we're going to search for table input. Connect that table to our apply color table. Double click. We wish to define this as color type. I can do that from a file, which is going to give us a color amp from cold blues up through reds to greens and whites, indicating very healthy vegetation up at the high hot colors of green and white. In case we want to have a different color table, we're also going to add a prompt. We'll turn on the input port so that we don't have confusion with background values. We're also going to make sure we don't have any zeros or no data zeros in our output using the max function. We're going to take the maximum pixel value of either the input values or 1. And we are going to feed that into a raster output operator to actually produce output information. We'll also preview again. Now you can see a much more visually appealing and easy to interpret representation of vegetation health. Now that we have the basic model working the way we want it, we're going to save it, give it a name. And because we want to publish this into the Smart M.App environment, we are going to put some prompts in that will appear in the Smart M.App to prompt the user for various inputs that are required. So the first one we want is a port input on the raster input file name. We're also going to prompt for the sensor type. And the color scheme. And finally, we're going to prompt for the name of the output results from each of our analysis. And what we can do is each of these we're going to give unique names so that they are easier to interpret. For this one, input image, we could give it a description as well to pop up as bubble help. Do the same with the other ports. Save our changes again. We'll also give the overall model some information as well using the operator info panel. Including selecting an icon to be displayed. Go ahead and save our model again. And perhaps finally, we'll just tidy our model up a little bit by creating submodels. And for publishing a model, we don't need a preview. Remove that. Save. Now that we've created our analysis model in ERDAS Imagine, we want to go ahead and upload this to our Smart Map environment on the web. So at the top right corner, we have a login to Smart Map. We will click this. Credentials have already been provided, so I have logged in now to Smart Map environment. Having done that, I can now use the option to upload to Smart Map the selected model. Click that button. Brings up the upload dialog. Much of this information has been filled in from the model info that I've already provided. We'll go ahead and add a description and click OK. Once the message arrives, we can see that we have successfully uploaded our model to the Smart Map environment. So let's go ahead and switch environments to a web browser. So we're pretty much done with ERDAS Imagine. Go ahead and start a web browser. I shall go to my bookmarked Smart Map and log into the Map Studio for designing a new Smart Map. If we look in the recipes for published spatial models, we will see the vegetation health model that we just uploaded from ERDAS Imagine. Let's go ahead and select to edit that model. This will take us into the Spatial Workshop, which is a graphical editing environment, very similar to the Spatial Model Editor in ERDAS Imagine. Within this environment, we can see all our same sets of operators. We can go ahead and graphically add to the model, edit functions, select a particular model, look at the index that might be defined, and so on. Make whatever edits we wish to do so. Once we are happy with the way the model is presented, we can go ahead and select it and publish it. So if we now look on the list of published models, we will see vegetation health. Now that the model or spatial recipe is published, we can go back to the studio and we can select to create a new smart map. In the map editor, we have a small wizard where we can design our layout, resize how it is going to appear, and tell it what components we wish to use. So we're going to add a recipe from our published recipes. You can now see a list of our available recipes, one of which is vegetation health. We'll select that particular recipe and click OK. So one part of our smart map is going to be prompting for and executing a spatial recipe. We also want to display those results on a map. So we're going to see a list of my available maps. We're going to add a base map over which the results will be displayed. So those are our basic components, but we want actions to be performed in these areas. So on our spatial recipe, we're going to select some sample JavaScript, which is basically going to say once the recipe has been executed, go ahead and catalog the results out and send them to the map. And then on the map, we also want to add some JavaScript from our samples, which is going to go ahead and display that catalogued information resulting from the spatial recipe. We're going to give this a name. And save it. We have now created a smart map for vegetation health analysis on any data we may have catalogued. So let's go ahead and launch in a new web browser that particular smart map. It's going to go ahead and on the fly build based on the template that we provided. It's going to load the base map information. We can zoom and roam around. We're going to fill in the information to the spatial recipe. Select our input image and provide an output name. And execute. The model is executed. The data will be catalogued and then displayed to the map. Once the data is displayed, we can zoom in on our results, and we can manipulate it, such as making it semi-transparent. And look at our particular analysis compared to the base map.